Okay, so in the last class we were discussing about the forced action. Okay, so as we have said, forced action, it is nothing but there are various cracks or fissures or joints or something which had been formed in the rock, and when water penetrates into these fissures, cracks or something, what will happen? It will obviously freeze when the temperature is being changing. So when this water freezes in these fissures, cracks or something, it will increase the volume or the size of the crack will be increasing. When again what will happen? Again when the temperature rises, what will happen? This ice or this frozen material again will be converted into water. So more water will be again added to this. Again this will freeze. So this freeze and thaw process will continuously move on for a particular period of time. So after this particular period of time, what will happen? This crack or fissure, it will enlarge and it will thus create a break in that massive rock. This will also cause weathering. So that part is we were discussing in the last class. So this is the continuation for frost wedging, that it nothing but there are certain other processes, that is forced heaving. There is another process which is the continuation of this forced heaving. So this is a simple example that we might have come across this thing, that it is just the lift rock and the soil vertically. That it is in this image you can see here, this is actually a road. So here you can see the snow, a snow falling area. So here is a road. So here you can see area. So yeah, here you can see various bulging, this bulges of this rock. This is actually happens because of this process, forced heaving. That is, the rock or the terrain is being lifted over. It is being lifted over. So this is the process. This lifting of the terrain or lifting of the rock, that is soil vertically, is known as what? Frost heaving. Okay. The solid rock conduct heat faster than soil. So why this lifting process occurs? It is why? Because the solid rock that will conduct this heat faster when compared to this rock and soil. As we know, rock will conduct this heat faster than the soil. So what will happen? In a cold day or in a cold place, the bottom of the partially buried rock will be much colder than the soil at the same depth. So rock will be partially, that is the rock will be much colder. When we compare the soil as well as the rock, what will happen? When coldness or the cold temperature, it will be high for the rock when compared to the same depth soil. That is the main reason why this bulging or the heaving happens. Okay, so then what will happen? As the ground freezes in winter, as we know, the ground is also expanding and contracting. So as the ground freezes in winter, this ice forms first under the large fragments in the soil. In the soil, these large fragments of ices will be firstly formed. Then what will happen? The expanding ice layers push boulders out to the ground. So what will happen? These layers will push the boulders to the ground. Thus what will happen? The frost heaving bulges the ground surface upward in winter. So in winter season, when these boulders particles are uplifted, the terrain also will get some upliftment. Thus it shows the breaking up of roads. So here in the figure you can see that various roads, it is being bulging up. The reason is that when the winter season, the soil, this will tend the boulders or the layers it will be pushing to the top layers, or the bottom layers will be pushed to the top layers. In such a way, heaving process will occur. Heaving process, it is nothing but the upliftment of various boulder sized particles from the soil in the winter season. That is the main reason why winter season, the roads nearby these areas or such areas is being bulging. Okay, and the process this happens is known as frost heaving, which is a associated process of frost wedging or frost action. Okay. Yes, now we can move to the next slide, that is salt crystal growth. Okay, in the figure itself you can see some white colored crystal growth, that is what is known as salt crystal growth. As we know, the color of the salt is white. So here also the crystal growth, it will be in whitish color. Okay. Yes, now you see salt crystal growth is also referred to as salt weathering or haloclasty. Yeah, so the name itself says that salt crystal growth, or that is same process or the same thing, it is known as salt weathering. Salt weathering, it is also known as salt weathering and also haloclasty. It is also known as haloclasty. So now you see how this process happens and how these salt crystals are grown up. Alright, so it occurs when saline solution enter the rock pores or cracks and evaporates, leaving behind salt crystal. It's very simple concept. Here in the second image you can see various cracks and fissures in the rock. Everyone had seen some fissures, everything in this rock. So what will happen is that when salt water enters to these fissures, cracks or vesicles, whatever it may be, what will happen? It will be completely filled with this salt water. Then what is the process? Obviously evaporation takes place. When these pore spaces or cracks are filled with this saline solution or salty water, after evaporation, what will happen? As we know, after evaporating, the salt crystals will remain in these fissures. Okay, the accumulated salt crystals are heated up when environmental temperatures are high and they expand, thus releasing pressure on the rock, causing the rocks to disintegrate. Yes, if this process is continuously done, means if these fissures or the small cracks, what will happen? These rock crystals will obviously dried up because the temperature is falling as well as rising. The temperature falls and temperature rises. Both these processes simultaneously occurs. So as a result, what will happen? These crystals will grow. That is, more accumulation will be there in these pore spaces. As this temperature variation is also present, gradually what will happen? This crystals or this salt crystals will enlarging, or more accumulation will be there in these fissures or cracks, and what will happen? Finally, this process will release a pressure on the rock, that is especially to that particular fissures or cracks. It will exert a pressure. Then what will happen? This will cause the rocks to disintegrate. So this is a main cause for the disintegration of rocks. Okay. Then again, another thing of this salt crystal growth is that these salts can expand threefold or even more. This phenomenon mainly takes place in drier and high temperature areas. So before we said about the frost action, it is usually in snow belt or snow areas, because this continuous drastic temperature pressure which changes is there in this glacier areas. So now in this crystal growth, it is mainly in high temperature areas. That is, during this high temperature only more and more salt formation will be favorable, or it will be present. So this is actually a drier area, whereas the frost action is actually for a moderate to cold climatic condition. It favors moderate to cold climatic condition, whereas crystal growth favors the drier or extreme heat climate. Okay, that you can always keep in mind. A prime example of salt crystal growth is witnessed in honeycombed stones in the seawall. Very simple example, you can even watch this thing when you visit some sea area. Yeah, it's obviously you can see this thing. So keep in mind the crystal, that is salt crystal growth. You can see in some pore spaces or some cracks, these kinds of salt will be present. And how the process, now we know the process how it is being formed. So hereafter when you visit some sea areas nearby, you should have to observe whether something is there or not, whether some cracks or fissures type rocks are there, is there any accumulation in that rock. So you should have to observe. Okay. Yes. Then now we should know what all are the factors which are responsible for this weathering process. Even though now we have came across various types of weathering process, you may know about the factors also. You can simply answer what are the factors which is responsible for various weathering. They are the factors, or it may be known as the agents of weathering. Okay. The agents of weathering determines the type of weathering. Yes, the main thing is that the agent will determine whether it is biological weathering, whether it is chemical weathering, whether it is physical weathering, or whatever the weathering type may be. Okay. In physical weathering, the agents are temperature and pressure. Yeah, as we know, in physical weathering, there is drastic temperature and pressure differences occurring. So, the main agents or the factors which is responsible for this physical weathering is temperature and pressure. Okay. Then moving on to this chemical weathering, the agents are air and water. As we know, there should be some chemical process that should have to occur in this chemical weathering. So, water is a major element. Then next is air. Air, in the sense, we know there are various gas molecules or various types of gases present in the air. For example, oxygen, hydrogen, carbon dioxide, various acids, water vapor, everything will be present. So, due to this air and water action, what will happen? The various minerals or various chemicals present in these rocks will disintegrate, or it may move like oxidation process, hydrolysis, or whatever the process may be, it will be eliminated from the parent rock. Thus, it favors the chemical weathering, or the result type of weathering may be known as chemical weathering. Okay. Sometimes living organisms which produce certain acids can also promote chemical weathering. Yeah. These living organisms, mainly we are discussing it in biological weathering, that is these both plants and animals, in certain time or a certain kind of animals which is promoting chemical weathering, which promotes chemical weathering, is also a part of chemical weathering. Some animals, they will produce certain kind of acids which will erode some kind of materials present in a rock. This also is considered under chemical weathering. Okay, so these all are the various factors which are responsible for various weathering processes. Okay. Now we should know the products of weathering. In the starting of this lecture, I just introduced you what is the main product of weathering. It is nothing but the clastic material or broken fragments, or it may be consolidated and can be said it as soil. Always remember that weathering process, the big huge mass will be always converting to the very fine material, that is soil. Initially it will be converted to broken fragments, then it will be very small pieces, then it will be dissolving, even though the final product, it will be the soil. Okay, or even though the soil also we can define, we can say it as dust. The end product will be soil, dust, like that. Okay. Anyway, let's see about the product of weathering. The product of weathering depends on the type of weathering occurred. Yes, here also, whether it is physical weathering means a particular type of product we will be receiving. If it is a chemical weathering means we will be getting some more other type of product. If it is completely biological means we will be getting the product in different way. So, the type of weathering, it is very much concerned with the product also. Okay. In physical or mechanical weathering, the product will be the broken fragments of a rock without change in their chemical composition. As we have already said, if it is physical weathering means there won't be any chemical alteration of the parent rock. Only the physical appearance will be changing. Sometimes it may be broken into 2 pieces or 3 pieces, or sometimes it may be broken into various fragments. Okay. Then these fragments will be later combined to form clastic sedimentary rock. What will happen? Obviously, these clastic materials or these broken materials combines to form various clastic sedimentary rock, that is a rock made up of broken fragments. Okay. So, it may also contain unaltered stable minerals. Not only these fragments, it also may contain some other kind of minerals also. Then, next is in chemical weathering. So, in chemical weathering, the product will be a new mineral with a different composition from the previous one, and there will be dissolved ions which got separated during the chemical reaction. As we know, there will be a chemical reaction which is being taking place in this chemical weathering. So what will happen after this chemical reaction? A particular compound of a particular composition will be formed, and also the parent rock also will be existing as a new compound with a particular chemical composition. Say for example, there was a rock that is calcium carbonate. So during various processes, this is just for an example, during various processes, this calcium and carbonate, if it is being separated and it is being formed as two individual rocks or whatever fragments, what will happen? There will be two products formed as a result of this weathering. That is, one rock is completely rich in calcium and one rock is completely rich in carbonate. Okay, so this is a simple example just to know this calcium and carbonate. So like that, various minerals, various soluble, insoluble minerals, hard minerals, soft minerals, so various minerals combines to form various kinds of rock masses after weathering. Okay, yes. Now here you can see the product of weathering. This is actually a representation. One side you can see the type of weathering. Next you can see the product of weathering and what type of erosion is present. Then in the third column you can see the type of sediment. What type of sediments will be present in various types of weathering. So first you can see that it is the physical weathering. Physical weathering is also known as mechanical weathering. That is nothing but the physical disintegration of rocks. Okay. So now we can say the fragments that is containing the same mineral as the original rock. Yeah, that is, there is no chemical changes, only the physical appearance of various things will be altered. So that is example, grains of quartz from a granite. That is, initially it was a granite, but these grains of quartz, it is being separated from that granite as a reason because of the physical weathering, or it is the mechanical weathering. The quartz piece or the quartz grains from the granite is being separated. That is a product of weathering. Okay. Then next is chemical weathering. Okay. Then here the type, okay, I forgot to say the type of sediment that is deposited in mechanical weathering. It is nothing but, as we know, it is clastic sediments because it is just breaking. Moreover, it will be large particles, that is clastic sediments and sedimentary rocks. Example, you can say it as sand, sandstone. These all are the examples of mechanical weathering or physical weathering. Okay. Then now when we talk about chemical weathering, as you know, the entire chemical composition of the rock mass will be changed and a new compound will be formed of a particular chemical composition. That is, new solid mineral particles formed by chemical reactions during weathering. Yeah, during the weathering process, what happens? New chemicals combines to form new mineral. That is, a new solid mineral particles formed by chemical reactions during weathering. Okay, all right, and you can see the example, that is clay minerals. Clay minerals are usually formed in the process of chemical weathering. Okay. The next is material dissolved in water. As we know, there are various soluble minerals. Say for example, calcium carbonate, CaCO3 will easily dissolve, or these ions are easily dissolved in water. Yeah, the example is given, that is calcium ions. Okay. Then the type of sediments that is formed in this chemical weathering is that in two types. That is, if it is being changed or the chemical composition is being completely changed and a new material is formed, means that we can expect clastic sediments. That is usually sand, sandstone or something that can be expected in this chemical weathering also. Then if it is dissolved or it is leached in water or something, means we can expect a chemical and a biological sediments. That is, if it is rich in calcium, means we can expect some limestones. Then another is that dissolving water is various salts present. That also, example is rock salt. Rock salt is an example for chemical weathering. Okay, after chemical weathering, the sediments, that is actually rock salt. Okay, so this rock salt and limestone, they are the example for the sediment deposit after chemical weathering. Okay, so this all are considered as the product of weathering. Yes, then we can move to the, yeah, here you can see various Yes, based on this thing, we are dividing the product of weathering as different types of mineral groups. Okay, first is lithic. Lithic, the rock, that is the lithic, the word represents, so the word means rock. That is rock fragments. It is nothing but the broken pieces of a particular rock. Sometimes if a rock is made up of various calcium, quartz, feldspar or something, if it is broken means we can easily identify one piece of calcium, one piece of feldspar, one piece of quartz and one piece of other materials. That is lithic fragments, or the lithic, the word denotes or the word meaning is rock. Simply lithic fragments or rock fragments. Okay. Then example is also given: granite, basalt, schist, etc. can be considered as lithic fragments or rock fragments. Next is dissolved ions, that we have already said what is being leached in water, or what can water carries, or water can easily erode various minerals present in a rock. This consists of this dissolved ions, that is calcium, potassium, sodium, etc. So these are dissolved ions. It means that what all are the materials that water can erode, or water can transport, or water can leached out from a particular rock mass, that is dissolved ions. Okay. The next is residual minerals, that is what is present, whether it is hard material or it is some soft materials, whatever the things is finally present, that is known as residual minerals. So here you can see the residual minerals are divided into three. One is stable mineral, the other is rust mineral, third is clay minerals. There are three types of residual minerals. One is stable minerals, second is rust minerals, and third is clay minerals. So what is stable minerals is that they are very hard and they are very resistant to various type of weathering. First of all, as we know, the more resistant or the most resistant rock is nothing but quartz, because quartz formed at 573 degree Kelvin, 573 degree Kelvin. Okay. Why? Because it is forming at very last, because it is very resistant rock when compared to other kind. Okay. So it is forming at very low temperature, that is 573. The very high temperature is spinel, olivine, everything is there, 1400 degrees for olivine. So above that spinel will be formed, first forming. At last forming mineral at 573 degree Kelvin is quartz, because it is very resistant to this weathering process. It is a stable mineral. Next is orthoclase and next is muscovite. So these are the examples of various stable minerals in residual mineral. Alright. Next is rust minerals. There are various rust minerals. For example, hematite. Hematite is a rust mineral. Then next is georite. Georite is also another type of rust minerals in residual mineral. Okay. Then finally, next is clay mineral. Okay. That is, in residual minerals, we can see some clay minerals also. Say for example, bentonite and montmorillonite. So this montmorillonite and this bentonite are the examples of various clay minerals present in residual minerals. Okay. So try to know all these things. What are the various types of product, or the various types of product which is formed after the weathering, and try to remember at least one or two names. So it's just for an example and just for your better understanding what all the things will be formed after weathering. Okay, like that. Yes. And now here the common rocks that are formed, the weathering product of common rocks forming minerals during the chemical weathering. This is a small list. So this also you can try to remember. Sometimes it may be helping you for some competitive exams. They will have a very in-depth question in chemical weathering. So this column will be very helpful for you. That is, the original mineral is feldspar. Then the main solid product is clay mineral. Then other product formed are sodium ions, calcium, potassium, SiO2. Okay. Then ferromagnesian minerals means that also form clay mineral. Then other ions is sodium, calcium, potassium. Then there is magnesium, because it is ferromagnesian minerals. Then almost SiO2 is there, and also iron also present. Then muscovite mica, that also obviously forms clay minerals. There we have the soluble product as potassium and SiO2. There is silica and potassium. Then quartz, as we know, it is only sand and silt. that is quartz grains will be formed. There is no other product in quartz, only the sand and silt. Then calcite, there is no particular product, only we can see this calcium and HCO3, nothing else is formed. So this will be the soluble product, that is CaCO3. So that will be the product, calcium carbonate. Both this calcium and carbonate will be, and this will be mostly soluble, that will be forming as the calcite when it is when it undergoes chemical weathering. Okay, so these are the basic concept of weathering and what are the various types of weathering and what are the agents of weathering, then how we can define or how we can distinguish various product of weathering. Okay, thank you.